Today we're going to be talking about how to find linear regression equations. This is section 10.2 in your book. Okay, so first of all, a linear regression equation is just basically how to find a line of best fit for a scatter plot. So I put an example on the screen here of a scatter plot that is comparing the size of a house in square footage to the price in thousands of dollars. Okay, so we can see that there's definitely like an uphill trend to this data, but what we want to be able to do is to find an equation for a line of best fit, or as we call it, a least squares regression line. So it really wouldn't make much sense for me to draw a line of best fit like this. Too many points are above the line, not as many points are below the line. So even though that line could estimate a fair amount of points in that scatter plot, it's definitely not the best line of best fit. Likewise, I wouldn't want to draw my line of best fit up here. Again, there's too many points below the line. There's only really 1 point above the line. And so there is a line that better fits the data than that. And we're going to pretend that that line is straight. So that might be the line of best fit, or the linear regression equation that we would want. We are not actually going to be doing these by hand, ladies and gentlemen. We're going to be relying on the calculator. We're going to be entering the data into the graphing calculator and asking the graphing calculator to find a least squares regression line for us. But it is good to just talk about what might be a good fit for a line and what would not be a good fit. Okay, so here is the first example that we're going to walk through together, and this data set may look familiar. It's one that we talked about yesterday when we were talking about making a scatter plot and finding the correlation coefficient. But today our goal is to find the equation of the least squares regression line, or line of best fit, or linear regression equation, whatever you want to call this line that is going to best fit the data and be used to hopefully predict points. Okay, so let's first go to our graphing calculator and let's enter this data. So we go to Stat and enter on Edit. We are going to put homeworks completed in list 1 and final grade in list 2. Okay, I finished entering those points, homeworks completed in list 1 and final grade in list 2. We're going to go to Stat and over to tests. There are a couple different locations where you could ask the calculator to find the linear regression equation, but we're going to use the same menu that we used yesterday. So Stat over to tests, and we're looking for the one that says linreg t-test. Go ahead and click enter on that. This should already be set up for us from yesterday. So we want our X list to be list 1, our Y list to be list 2. We should have a frequency still of 1, and we're going to highlight the not equal to case. Right here where it says reg EQ, if you would like, this is not mandatory, but if you would like to be able to paste the regression equation into your Y1 menu in order to make it easier to graph, you can do that by clicking vars over to yvars, enter on function, and enter on y1. You do not need to do that, but again, if you're planning on graphing these, it might be easier to see the scatter plot with the line of best fit graphed on it. And that's how you do that. Okay, we're going to go to calculate. The very first thing that pops up on your screen is the form that we write the regression equations in. Y equals A plus BX. If you give it to me in Y equals MX plus B form, it's fine. I will accept that. It's an equivalent equation. But if you're using the calculator, that's the form that you're going to be seeing. Further down on that calculator screen, you're going to see an A equals value and a B equals value. Those are the values of the y-intercept and the slope. So if we plug those values into the equation, y equals the A value, according to this, is 24.0 I'm going to round that to 3 decimal places. Plus the slope, the b value is 1.588. Again, rounded to 2 decimal places, x. So that is the equation of my least squares regression line, or my line of best fit for this particular example. If we are asked to graph that, we could graph the points by hand and then graph the line of best fit equation by hand on that graph. Or we could go ahead and see the scatter plot with the line of best fit on the calculator. So I'm going to use that technology. So I'm going to hit second y equals. This should already be set from what we did the other day with drawing scatter plots, but just to re-emphasize, we want to turn plot 1 on. We want the first type of graph, the scatter plot. X list should be list 1, Y list should be list 2. We're going to hit graph, and then we always zoom stat, or zoom stat is number 9 in the graphing calculator. So since I stored the regression equation in that menu, it is showing me both the scatter plot and the line of best fit graphed. If I did not want to see that line of best fit, I could turn that off, and there is just the scatter plot without the line of best fit. Okay. So what we're going to have to do is we're going to have to interpret these numbers. So looking at my equation, I see y equals 24.715 plus 1.588x. But if I think about what y and x are representing in terms of this scenario, y is representing the final grade, and x is representing the homeworks completed, the number of homeworks completed. If I were to graph this by hand, my y-intercept value is 24.715. So that is the point where it's going to touch the y-axis. In order to get to my next point, I would use the slope. So I'm just going to put that slope over 1. I would rise 1.588 and run 1. So if you remember from your algebra class, the numerator is the rise, the denominator, in this case the 1, is the run. So if I go up 1.588, I would go over 1. And I would continue to do that until I get some type of a line. I'm just sketching this for right now. Okay, so the slope we said was 1.588 over 1. So if I think about what the rise represents, the rise means the increase in final grade. So the final grade is going to increase 1.588% for every 1. The run is representing the homeworks completed. So that increase of final grade of 1.588% for every 1 homework completed. I would want to make that into a sentence, which I'm going to show you that sentence in the very next slide. Let's talk about the y-intercept for a minute. The y-intercept in the equation was the 24.715. In order to graph that, I went to the y-axis and I just went up to that number, 24.715. So that number is still representing a y value. It's representing final grade. But I didn't move left or right at all to get to that y-intercept. All I did was I went straight up. So that means the homeworks completed would still be at 0. So basically I'm saying if I don't complete any homeworks, for 0 homeworks done, I'm going to predict that my final grade is going to be 24.715% for this particular class. So when we interpret the slope and the y-intercept, we do want to make those into sentences. We want to write a complete sentence for those. So looking at those sentences, I have, for each additional homework completed, the final grade is predicted to increase by 1.588 points. That's my interpretation for slope. For y-intercept, the predicted grade will be 24.715% when there are 0 homeworks completed. So our interpretations, we want to be written out in full sentences and be in the context of the prompt. So we don't just want to say X equals or Y equals. We want to talk about, in this case, homeworks completed and final grade. Okay, here's the U-Try, guys. This data set, again, is a data set that we looked at yesterday. We're comparing number of absences a student has with their final grade in the class. I would like you to first find the equation of the regression equation and then interpret the slope and the y-intercept in the context of the prompt. So talking about number of absences versus grade. Go ahead and pause the video. When you find those values, unpause the video to get the results. Okay, hopefully you've had enough time to calculate those. The first answer, the regression equation, y equals 87.777 minus 1.905x. Again, I entered those points or those values into the stat edit screen, and then I went to stat, over to tests, and picked the LinReg t-test. We can see that the A value and the B value are the values that I substituted into that equation. Be careful, those negative signs are very easily missed, so be watching out for them. Number 2, interpreting the slope, we would be interpreting this negative 1.905 number. So my interpretation would sound like, for each additional absence, the predicted final grade decreases by 1.905%. Interpreting the y-intercept, I would say a student is predicting to get a grade of 87.777 when there are 0 absences. Okay, guys, that's basically what we're going to have to do for today. We're going to have to find equations for lines of best fit or linear regression equations or least squares regression line equations. These have many different names, but after we find the equation, we're going to have to interpret the slope and the y-intercept in the context of the prompt. So basically, you're going to write a sentence for the slope and write a sentence for the y-intercept. Just a quick, little item to be careful of. These linear regression equations are only useful for data that is closely fitting a line. So if I look at the graph for this last example, we see that the data might not be linear. It kind of looks like there's a curve that might fit the data better for this one. So even though I did the equation for the line of best fit, there might be an exponential equation that would better fit these points. But for right now, we are only talking about linear scenarios. So we will only be finding equations for lines of best fit. At this point, we are not going to be finding curves of best fit. But I just wanted to point that out in case you looked at the graph and thought that a linear might not be appropriate. And if so, you may be right. All right, guys, that's it for today.